ये तो अभी सब सोते रहते हैं. Okay, so we are ready. We started this topic logic, and we have looked at proposition logic, and then we started predicate logic, right? Where there are quantifiers for every there exists those kind of things, right? And some statements whether they are true or false, we can look at it, right? Now I have to do the negation of quantifiers. I will define negation. How do you do the negation of a quantifier? I'll look at a couple of examples. And then we are going to look at De Morgan's for quantifiers, in terms of negations, how it works. Then especially for two variables, what we can do with the quantifiers. And one more example. After that, I'm going to look at Boolean algebra. So you know Boolean algebra, right? In the previous class, what was going on? Boolean algebra. So you know Boolean algebra? It's easy. Yeah, so 1 plus 1 is equal to 1. Until now you saw 1 plus 1 is equal to 0. So now you can understand anything is possible. This is the beauty. So anyway, so we will cover basic, very basic, because it is a part of the topic, because and it is kind of needed in electronics. That was electronics class, right? Digital logic. So normally I ask one very nice questions in logic. If there are resistors 1 ohm, 2 ohm, 3 ohm, 4 ohm, 5 ohm, dot n ohms in parallel, what is the effective resistance? So 1 over R is equal to, yeah, 1 plus 1 by 2 and so on up to 1. So R is equal to what? 1 divided by 1 plus 1 by 2 plus dot order 1 by n. फिर क्या करेंगे? अभी तो प्रॉब्लम फंसी. So now 1 plus 1 by 2 plus 1 by 3 up to 1 by n. So 1 divided by that quantity is effective resistance. And then how do you find a complete formula for it? Finding a formula is a difficult task. You will realize pretty soon. Sum up to harmonic series of sum of a harmonic series up to n terms. Finding a compact formula is a difficult task. I mean, you will not be able to find, right? What will you do? So I ask you effective resistance, you are giving an answer in series. I want you exact answer. Sochna T problem, right? But anyway, so that is something. Logic, so circuits are very important, so as I mentioned to you that it is circuits and VLSI which are very, very important for you to understand ICT. It's very easy to understand. Anyway, so let me start. You see, last time we looked at proposition logic. We have truth values, true or false, proposition, small PQR, like that. And then there are P, negation of P, truth table for it, conjunction, join. This is known as meet, P meet Q, P join Q, and so on. Exclusive OR and conditional statement, P going to Q, P implies Q, biconditional, compound proposition, then precedence, which one will come first if there is an expression, how do you evaluate that? Then tautology, logical equivalence. So whenever we want to look at the logical equivalence in propositional calculus, so what we do, we just look at the all variables, and now you see this column and this column has the same truth values, right? So that means they are same logically. Okay. Then predicate logic, we talked about. So it is basically P of X where X is greater than C. So basically now you are defining truth or falsity of this kind of statement. So P of 4 is true, P of 2 is false, and so on, right? So quantifiers are these kind of expressions for every x px. So this is known as universal quantifier. Okay. Then we looked at statement for every and there exists, when it is true, when it is false, right? These things. I'm just recalling what was done last time. Logical equivalence of involving quantifiers. So I have shown you this example. For every x, px meet qx, the same thing as for every x, px meet for every x, qx. Okay, and then we saw the small proof of this fact. This was fun thing anyway. Okay, so now a few more things I would like to discuss. Negation of quantifiers. I will start with an example, and so that you understand what is going on. So we are starting with an example. For every x, px is that every student in your class has taken a course in calculus. Right? So this is your statement. For every x, px means every student in your class has taken a course in calculus, which is true anyway, right? You have done a course in calculus. Now, if you apply negation, px, what does that mean? It is not the case that every student in your class has taken a course in calculus. Right? When we put a negation, this is equivalent of saying that there is a student in class in your class who has not taken a course in calculus. So this is the negation. That means I can write it like there exists x negation of px for the whole thing, right? So px is statement that a student is taken a class, right? And x is over that range, right? For every x. So that means we have found that negation of for every x px the same thing as there exists x negation of px. So this is a negation of a quantifier. This was a universal quantifier. This is same thing as there exists x such that negation of px holds, right? Okay, it's a very simple thing. So I can summarize kind of a table some of these things, and those things are known as De Morgan's law for quantifiers. Okay, so the first thing, negation. equivalent statement. When is negation true? And when false? Negation of there exists x, px. Equivalent is for every x, negation of px. Right? That means for every x, px is false. When false, there is an x for which px is true. Second, negation of for every x, px. There exists x, negation of px. So there is an x for which px is false. And here px is true for every x. So these are nothing but De Morgan laws. So I have shown you one and then I have written all of them, all the possibilities. De Morgan's law for quantifiers. Okay. Now quantifiers, I can talk about nested quantifiers. So something like this, for every x, qx, where qx is, there exists y, pxy, there pxy is x plus y is equal to 0. So this is a nested quantifier, example of a nested quantifier, right? We can say that d is a real number, our domain is a real number. Then we can say that for every x, there exists y, x plus y equal to. So for every real number x, there exists y such that x plus y is equal to 0. This is a possibility. Okay. So now I can write it down quantifiers for two variables in a table, which are fairly straightforward to look at. Two variables. A statement when true, when false. For every x, for every y, pxy. For two variables, quantifiers. So that means pxy is true for every pair of x comma y. So for every x, for every y, pxy, two variables, right? So when it is true, so pxy is true for every pairs of x comma y. Okay. And when false, so there is a pair x comma y for which pxy is false. Okay. Next statement, for every y, for every x, pxy. This time y is ahead, then x, So basically this is also same thing, pxy is true for every pair of x comma y. there is a pair xy for which pxy is false. Okay, we go to the next one. For every x, there exists y such that pxy. That means for every x, there is a y for which pxy is true, right? So for every x, there exists a y such that pxy is true, right? This is how, when this is true. And when this is false means what? False means there is an x such that pxy is false for every y, right? Next, there exists x for every y pxy. So there is an x when it is true. There is an x for which pxy is true for every y, basically, right? Again, I'm using shorthand, but I mean, that's okay. And when it is false, for every x, there is a y for which pxy is false. And the last one, there exists x, there exists y, pxy, or there exists y, there exists x, pxy. In both the cases, this is true. So there is a pair x comma y for which pxy is true. And when false, pxy is false for every pair x comma y. I'm again using the shorthand. I should have not used it, but I guess the context is clear, so I'm writing it right. So this is a summary of two variable quantifiers for every x, for every y, pxy, for every y, for every x, pxy. For every x, there exists y, there exists x, for every y, and there exists x, there exists y, there exists y, there exists x, right? So I think this context is very clear, right? So simple English, right? And you are expert in English. Okay, I'll give you one example, then we can move to the next. After the one example, we'll move to the Boolean algebra. Okay, and then maybe I'll see if rules of inference we can start. Yeah, we will start. I guess we have enough time, but let's see. Example. Qxy is the statement x plus y is equal to 0. So what are the question is, what are the truth values of the quantifiers? There exists y, there exists y for every x, qxy, and second, for every x, there exists y qxy. X and y are real numbers. The domain is specified. So which one do you think is false? Which one is true? There are two quantifiers given to us. There exists y for every x, qxy. So this says there exists a real number y such that for every x, x plus y is equal to 0. This says that for every real number x, there is a y such that x plus y is equal to 0. Which one is true? Which one is false? Second is true. Very good. First one is हो गया काम खत्म. You got how and why just written in some English, right? The first one is false. Second one is true. Because for every x, you will be able to produce a negative number y. But the first case is not possible, right? So this is false and this is. Okay. So I think this is, should write it down. This is true. Okay, Boolean algebra is now we can move to the Boolean algebra stuff. So you might have studied geometry, right? One line has how many points? Discrete मैथ्स की क्लास है तो दो ही होंगे ना. So one line has only 2 points. Discrete है. Plane has only 4 points. Right? Cube has only 8 points. 4. Cube में कितने होते हैं? 4 होते हैं, 8 होते हैं? 8 होते हैं, 4 होते हैं. I think that's. Anyway, so let us see. And you know, by the way, how to make it. Like, so you take a calculus, you might have done this, right? Take a point, stretch it, you get a line. Take a line, stretch it, you get a plane. Take a plane, stretch it, you get a cube, so on, right? Hypercube कैसे बनता है? You take a cube and stretch it in one direction, so you get a 4-dimensional cube, and so on, right? Okay. 4 dimensions. So basically take a cube. यहाँ पे कुछ है? Cube जैसा तो नहीं है, but ये रिमोट है. ठीक है. हाँ, ये तो क्यूब है इसके पास. So you take the cube and take every point in the cube, stretch in one direction, where all the previous points will remain at the same place. So what happens? Dimension will increase by 1. Getting my point? How we are getting line from point? We are stretching a point. 0 dimension से 1 dimension में जाने का यही तरीका है. You stretch in one direction. Now, if you have a line which is in 1 dimension, you stretch line to plane. You stretch everything, so you get plane. 2 dimension में आ गए. Take a plane in 2 dimension. Stretch every point in the plane. So what will happen? You get a cube. अब क्यूब तक तो समझ में आता है, इसके बाद बुद्धि काम नहीं करती है. So 3-dimensional cube को if you stretch in one direction, you get 4-dimensional cube. Right? So in some direction, you have to put it in some direction. So if there is a cube is there, stretch it in one direction. I can show you, but थोड़ा सा complicated होता है picture draw करना, but I will show you. What is this? This is a cube. I am stretching it in one direction. and you join these things, you know. This, 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 और कोई बचा ये वाला आ गया ना. This is stretching. Right, you're getting the point, right? Everything is stretched in one direction. So you get, so you can keep on continuing this. By the way, there is one nice, what is the volume of unit sphere in infinite dimension? This has a lot of connection with spiritualism, you know. What is the volume of unit sphere in infinite dimension? Any answer? Answer is 0. That is the beauty. I mean, the proof is very simple. You can write down volume of a unit sphere in n dimension. It will be function of n. You will see that function has largely dominated by power of n. When you take limit n tends to infinity, whole thing goes towards 0. Simple. Calculus में पढ़ा होगा, right? Anyway. So Boolean algebra, George Boole. B is a set 0, 1. Complement of 0 is 1. Complement of 1 is 0. Denoted by this set. We have Boolean sum, or we call it as OR. 1 plus 1 is equal to 1. 1 plus 0 is equal to 1. 0 plus 1 is equal to 1. 0 plus 0 is equal to 0. Boolean product. 1 into 1 is equal to 1. 1 into 0 is equal to 0. 0 into 1 is equal to 0. 0 into 0 is equal to 0. Question I can ask, is it a field? Confuse karo thoda na. Is it a field? फील्ड का मतलब क्या है? जहां खेल सके हम लोग. तो यहाँ पे खेल सकते हैं क्या सारी चीजों से कि नहीं? सोचो, चाय की प्रॉब्लम है, ठीक है ना? टी टाइम प्रॉब्लम, थिंक अबाउट इट. शाम को चाय भी तो पीनी है, राइट? Okay, and we can have some sort of expressions. 1, 0 plus 0 plus 1 complement is equal to 0 plus 1 complement is equal to 0 plus 0 is equal to 0. All these Boolean expressions. By the way, if you want to make a career in cryptography and security, so I'm going to write one thing known as Boolean function. Very important for cryptography and security. Boolean functions. I'm sure if you search on Google, you will find a book, Boolean function and its application in cryptography. So something related to Boolean functions takes n input and 1 output. That's all. With bits, n bits as an input and 1 bit as an output. So output is either 0 or 1, right? Those are known as Boolean functions. So I can write it down. I can form Boolean space B, or B is 0, 1. A function f from Bn to B is called a Boolean function. I am writing shorthand, right? Boolean function. So there are a special kind of Boolean functions known as bent functions. B-E-N-T, bent functions. Very useful for cryptography and security. Bent functions. तो सर्च करना आजकल मोबाइल तो है ही, कभी बैठे बैठे शाम को व्हाट इज बेंट फंक्शन, हाउ दे आर यूज्ड इन क्रिप्टोग्राफी, यू कैन लर्न मोर अबाउट इट, राइट? बेंट फंक्शंस. So here is an example. Is a Boolean function of degree 2 for every x comma y belongs to b square. It's a Boolean function taking 2 bits and giving you 1 bit, right? Which is either 0 or 1. Output is 0 or 1. Boolean function पढ़ाया है इलेक्ट्रॉनिक्स में? नहीं. That is interesting. Let me do some calculations. If the Boolean function is given as f x comma y comma z is equal to x y plus z bar. Z bar means complement, right? So I can make a table. Using the values which I told you earlier, I can compute 1, 1, 1. So x into y is 1. Z you can take 0. This value is put this 1, 1. X is 1, y is 1, x into y is 1. Z bar है ना ये? So I am saying that this is Z0. So the complement, so x into y is 1. 1 plus Z bar. यहाँ पे ना? Yes, that value will be there, right? So then, so the value is Z is 1. Yeah. So if Z is 1, so this is Z bar, correct. So this value 1, 1, 0. This 1, this is 1. 1, 0, 1. 0, 0, 0. 1, 0, 0. 0, 1, 1. 0, 1, 1. 0, 0, 0. 0, 1, 0. 1, 1. 0, 0, 1. 0, 0, 0. 0, 0, 0. 0, 1. This is a simple calculation. You can do it, all the time. One can ask one question: how many Boolean functions are there of degree n? Degree n, 2 raised to n, right? Because there are n possibilities. Each one will have 2 choice, 0 or 1. So 2 raised for n. Okay, I think one more identity we can do. X times y plus z is equal to xy plus xz. By the way, Boolean functions were first used in 1967 for Mars space, US has sent a spacecraft to Mars. They have some numbers, So 61, so 66 they sent one spacecraft and they took pictures of Mars. It was very hazy picture, so it was not very clear. But then they used Boolean functions to construct a error correcting code known as Reed-Muller code, and they used Reed-Muller code to send pictures of the Mars, and they were crystal clear. All the errors were corrected. So these are very useful things. What you see right now, Boolean function, beautiful thing, I would say, right? You can see plenty of beauty here and there about Boolean functions. So if you master Boolean function, you will become expert in cryptography. You will become expert in error correction. Whenever data is sent from one place to other place, and so on. So wide variety of application. And also you will become expert in VLSI and all that. You see electronics, digital logic everywhere. Boolean functions are pretty useful thing actually anyway. So if I have to show you that this identity x into y plus z is equal to xy plus xz, how will you show that? Truth value, just substitute everything and then you can check that, right? I leave it as an easy exercise for you because now this is a high school level problem, right? Right? So I can assume that you can do this. So there are certain properties which are known as Boolean identities. I'm just going to talk about it. X complement is X, known as law of double complement. X plus X is equal to X. Right? Idempotent law. X plus 0 is equal to X. Identity law. X into 1 is equal to X. Commutative law. X plus Y is same thing as Y plus X. X into Y is equal to Y into X. Okay. Associative law. X plus Y plus Z is equal to X plus Y plus Z. X into Y into Z is equal to X into Y into Z. X plus Y into Z is equal to X plus Y into X plus Z. You know what is happening here? Plus is distributive over this multiplication, right? I hope you observe that. X plus Y into X plus Z. Similarly, X times Y plus Z is equal to XY plus XZ. These are known as distributive law. Then we have De Morgan's law. XY bar is equal to X bar plus Y bar. See? Right? हर प्लस का अपना अलग मतलब है, हर मल्टीप्लिकेशन का अलग मतलब है, जो मन में आए करो, राइट? तो x plus y bar is equal to x bar into y bar. Absorption law are pretty interesting. X plus xy is equal to x. X times x plus y is equal to x. ये De Morgan law थे और ये absorption law है, right? Unit property, x plus x bar is equal to 1. X into x bar is equal to 0. Zero property and unit property. So you may ask, what is the proof of this fact? All these things, whatever I have written. The proof is in your cup of tea. You take cup of tea and then write down the values, right? And then see that everything is proved. तो शायद कितनी कप पीनी पड़ेगी, 15-20 कप पीनी पड़ेगी चाय नहीं, बट शायद एक कप में तुम 4-5 निपटा दोगे, राइट? सो आई होप दैट इज इजी. So after telling you all this business, by the way, also you should note that, yeah, one thing that I would like to mention here, these statements, the Boolean statements like x plus y into z is equal to x plus y into x plus z is equivalent to E join Q meet R. Do you agree? प्रोपोजिशन लॉजिक में आ गया ना सब, एक दूसरे का जिसका जो मन में आए वैसे सिस्टम सिंबल्स बनाओ, अपना काम करते रहो, राइट? तो यस, लेट मी चेक, आई थिंक P. Good. So mistakes are a very common thing, right? Everybody makes a mistake. And Von Neumann has said once, whenever there is information processing, errors are bound to happen, right? So if it is any computer, it will make a mistake, and you need error correcting codes to correct the errors, right? Whenever we are speaking to each other, if I say something you are not able to understand, what will you say? Please repeat. Repetition is the crude form of error correction. So error correction has to be done. So this guy has corrected the error. So, okay, so now the last thing that talk about is the actual definition of Boolean algebra. Whatever I have done is the machinery to give you the definition of Boolean algebra. George Boole, right? Boolean algebra. Okay. BA. I write down everything in short form. So Boolean algebra is a set E with join, meet, and complement operations such that, so two binary operations, these are two binary operations, and this is a unary operation. Binary operations means taking two input, right? Unary operation means taking one input, okay? Unary operation. So this is a Boolean algebra provided we have following properties for every x, y, z in B. First property, x join 0 is x, x meet 1 is x. These are known as identity law. Second, x join x bar is equal to 1, x meet x bar is equal to 0. Complement law. Third, associative law. And x meet y meet z is equal to x meet y meet z. Associative law. Two more laws which I can mention. So identity law, complement law, associative law. Then we have commutative law. X join y is equal to y join x. X meet y is equal to y meet x. Fifth, distributive law. X join Y meet X join Z. X meet Y join Z is equal to X meet Y join X meet Z. So using these 5 properties, so a Boolean set B with these 5 properties: identity law, complement law, associative law, and this commutative law. So this is commutative law. And distributive law. You can prove the following things. What is T problem? First, X join X is equal to X, and X meet X is equal to X for every X in B. You can use the above formulas to actually derive these expressions. In second, 0 bar is equal to 1 and 1 bar is equal to 0. Third, X join Y complement is X complement meet Y complement. X meet Y complement X complement. So this you can prove. It's not very difficult to use the formulas, which are at the top. So okay, so this is all about Boolean algebra, right? You don't require much more than that, at this point. So the most important thing, Boolean algebra, is study of Boolean functions. Okay, as I mentioned, they have wide variety of applications. If you can get expertise, so construction of Boolean functions, certain Boolean functions, which have applications in cryptography, security, and so on. Okay, so that is important. It is 5:10. So 5:10 or 5:08 anyway. So we can start maybe some idea about rules of inference. So now there are 2 topics in logic: rules of inference for proposition logic and for quantifiers. And then there is one more topic left, is normal forms. That's all. So logic will be done. So 3 lectures for logic will be over. I think in some of the discrete mathematics courses, they cover set theory. I'm not doing a lot of set theory because you know set theory, right? You are able to answer that question that I asked in the first lecture? Give an example of a collection which is not well defined. What is that collection? Favorite cricket player. Collection of favorite cricket player. In what sense? So if you fix the sense, then it will be well defined, right? Okay, yeah. So yeah, something. So basically, what is the meaning of well defined? So if given a collection and an element, you will be able to say for sure that this element belongs to this collection or not, right? If you cannot say for sure, then that means the collection is not well defined. सेट थ्योरी में 2 ही चीजें, एक तो ये प्रॉब्लम पूछता हूं मैं, दूसरा वो बार बार पैराडॉक्स सुना है ना, बार बार पैराडॉक्स. There is a barber in the city who is shaving everyone who is not shaving himself. Who will shave barber? So, but set theory में इतना ही है, ये 2 प्रॉब्लम है. So in a city there is a barber who shaves everyone who will not shave himself. So who will shave barber? Russell paradox. This is known as Russell paradox. Right. So it's an interesting thing, But set theory has been generalized to what is known as fuzzy sets. And fuzzy sets have application in your washing machine. See the beauty of math. So, okay, so fuzzy sets, I think you have not studied, so it's something interesting, which is not part of any way or topic, but anyway, so I think that's all for today. In the next class, we will start rules of inference.